Hello everyone, this is chapter 10. I'm going to help you with some problems over here. So the first one, which one of the following Lewis structure is definitely incorrect? And in the lecture you had learned how to draw the Lewis structure, and there are certain criteria that you want to meet when you are drawing a Lewis structure, and there is a process that you have to follow. First you have to find out the number of valence electrons, then you have to figure out what's going to be in the center, and then you put the skeleton structure, and then you put the bonds. Each bond has 2 electrons, so you fill out giving everybody an octet. Okay, first you fill out the electrons in the outer atoms, and then you go to the central atom. And in some cases we learned that could be expanded valence shells where you can have more than 8 electrons. Excuse me. In some atoms, some central atoms, it's okay to have less than 8 electrons. Okay, now here the first question is, which one of the following is definitely incorrect? So easy way that we can look up is, we can see what are the atoms that is deficient in electrons less than 8, and since we learned some exceptions, it's okay to have less than 8, so we can omit those ones. Okay, now the first one, BF3. So you can see all fluorines have 8 electrons, and the boron has only 6 shared electrons, and then the boron, aluminum, they are in group 3, and it's perfectly fine for them to have 6 electrons. So that is a correct structure. And then if you look at XeO3, oxygen has 8 electrons, and xenon is a atom that is period 3 and below. Period 3 nonmetals and below. So they can have more than 8 electrons. So in this case, xenon has 2, 4, 6, 8, 10, 12, 14 electrons. That's perfectly fine. And then you go to nitrogen. So the nitrogen molecule, if you look at the nitrogen, so here each nitrogen, the shared electrons that it's having is only 6 electrons each one. So nitrogen is missing a lone pair. Okay, so nitrogen need to have a lone pair like that, each nitrogen. So since nitrogen does not have 8 electrons and missing lone pairs, so the definitely incorrect structure is the nitrogen. And then the aluminum chloride, AlCl4. Aluminum, it's a valid structure. Aluminum has 8 electrons and also has a formal charge of -1. So out of all these choices, the nitrogen is the incorrect one. Which one of the following Lewis structure is definitely incorrect? So nitrogen monoxide, again you can count the number of valence electrons and see if the structure is drawn correctly. And so you have to draw the structure separately for each one. Okay, and if you draw SO3 2-, you will find that that's a correct structure too. Same thing for the NO2-. And then PCl5 looks like that's a correct structure too. And for the hydrogen cyanide, if you look at hydrogen cyanide molecule, you see here how many electrons carbon has. Carbon has shared electrons only 6. So then it's not the correct structure. So if you draw the correct structure for hydrogen cyanide, it would be like this, HCN. So we need to draw it like this. Hydrogen, carbon, it need to have a triple bond between carbon and nitrogen. So the incorrect structure is HCN. Which one of the following? Definitely incorrect again. So you have to draw all the structures, proper Lewis structures, and find out which one is the wrong one. NO2, that's correct. BeCl2 also correct. Carbonate also, the way it is drawn, it's correct. CH4 is also correct. Now if you draw the sulfur dioxide SO2, you will figure out that the sulfur dioxide molecule is like this. it need to have another lone pair on the sulfur. Okay, so making SO2 is the wrong or the incorrect structure. It's missing a lone pair. Now how do you find if it is correct or wrong? You have to draw all the structures according to the method that we have discussed in the lecture. Next one, select the best Lewis structure for ClCN. So the between carbon and nitrogen, it's a cyano group. Cyanide has a triple bond. So the correct structure is going to be this one, where you have a triple bond between carbon and nitrogen. The next one, select the best Lewis structure for NF3. So for nitrogen fluoride, again let me show you how to draw a Lewis structure. Remind you, you guys already know. So first you find out the number of valence electrons. How do you find the valence electrons? You look at the group number. Nitrogen is group 5, it has 5 valence electrons. Fluorine is in group 7 and there are 3 fluorines, so 7 times 3, 21. So 21 plus 5 is 26. And we put nitrogen in the center because it's the least electronegative atom. And then, so from 26 you have used 2, 4, 6 for the bonds. So you are left with 20. So these 20 electrons you put as lone pairs. So you put 6 there, 12 here, and then another 6 will make it 18. So there are 2 left. So that you're going to put on nitrogen. So that will give you the correct Lewis structure for NF3 as this one, right? The next one, again select the best Lewis structure for P2I4. Now for the P2I4, we can draw the Lewis structure from the scratch. So there are 2 phosphorus. What is phosphorus is in group 5. So 2 times 5, 10. And then we have how many iodine? 4. 4I. So each iodine will have 7 valence electrons. 7 times 4, 28. So there are 38 valence electrons. So there are 2 phosphorus. So between phosphorus and iodide, we're going to put phosphorus in the middle. Normally the halogens will not stay in the middle unless all of them are all halogens. Okay, so phosphorus going to be in the center, P2I2, and then you put I on each one. So now for the bonds, the skeleton we use 3 bonds. Each bond is 2 electrons, so 2 times 3, 6. So we use 6, so we are left with 32. Now you're going to put lone electrons. We put 6 there, 6. And then you're going to put, oh, I4. I'm missing 2 more iodine. Okay, let's change our electron count. Okay, so now for the bonds, how many have we used up for the bonds? So we have 1, 2, 3, 4, 5. So for the skeleton, we have used 5 bonds. 5 bonds means 2 electrons, 2 times 5, 10. So 38 minus 10, 28. So we are left with now 28 electrons to put on the terminal iodine to make them an octet. Okay, so so far we do 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we use 24 for iodine. So 28 minus 24 is 4. So there are 4 more electrons left. Okay, and those 4 we can put on each phosphorus because right now phosphorus has 6, 7, 8, 7, 8. Okay, so we have enough electrons to fill everybody an octet. Now we go to double bonds if you do not have enough electrons to fulfill the octet. Okay, so in this case now we distributed all 38 electrons. So the correct structure is going to be then B. Okay. Remember, we go to double bonds or triple bonds if you do not have enough electrons to fulfill their octet requirements. Okay, the next one. Thionyl chloride, best Lewis structure for thionyl chloride. Again, let's go ahead and draw this structure, SOCl2, SOCl2. So sulfur is in group 6, group number 6. Oxygen is in group 6, valence electron 6. So there are 2 chlorine. Each chlorine is 7 electrons. 7 times 2, 14. So 14 plus 6, 20, 26. So the total number of valence electrons are 26. Sulfur going to be in the center, and then you have one oxygen, and then you have another chlorine. Okay, now for the skeleton, how many electrons have we used up? We use 3 bonds. 3 bonds means 6 electrons. So we are left with 20 more electrons. So we're going to put them on our terminal atoms to make them octets. So we put 6 there, and you put another 6 over here. Okay, and then you put another 6 on oxygen. So 6 times 3, 18. So we are left with 2 more electrons. So if you put that on sulfur, okay, so you put it like that. Now what happened? We distributed all the electrons. Chlorine has 8, oxygen also has 8. What about sulfur? Sulfur has 2, 4, 6, 8. Sulfur also has 8 electrons. Now in this one, we can consider the formal charges. Okay, if you look at the formal charges, we want to make sure that all the atoms need to have minimum formal charge. Now remember how to calculate the formal charge. Let's look at chlorine. First we look at the group number. Chlorine group number is 7 minus the number of electrons and bonds on chlorine. So there are 6 electrons and 1 bond, making it 7. So 7 minus 7, 0. So the formal charge of chlorine is 0. Chlorine formal charge 0, and the same pattern for this chlorine, that is also 0. Now what about sulfur? Sulfur, this is how you calculate the formal charge. You get the group number. Sulfur group number is 6, and then you look at the number of bonds and electrons on sulfur. There are 3 bonds, and then the number of electrons 2, 5. So 6 minus 5 plus 1. So the formal charge of sulfur is plus 1. What about the oxygen? Formal charge, oxygen group number 6 minus the number of bonds. There is 1 bond on oxygen, and then the number of electrons 6. So 6 plus 1 is 7. So 6 minus 7 minus 1. So oxygen is minus 1. Now you can see that there is a plus 1 and a minus 1 formal charge. We can minimize the formal charge if you have 2 adjacent atoms. One is plus 1, the other one minus 1, meaning one is has more electrons, the other one is electron deficient. By putting a double bond between the 2, you can minimize the formal charges. Okay, so what's going to happen is one of the lone pairs on oxygen going to form a bond between sulfur and oxygen. Okay, so that will give us a molecule like this. Where can I draw it? Okay, let me find a place. Okay, so then when you draw the structure, it would look like this. You have chlorine, sulfur, double bond oxygen, chlorine, and then the chlorine will end up having its valence electrons. Okay, and then the sulfur will still keep it lone pair on it, and then oxygen gave its 2 electron. And now the sulfur has 2, 4, 6, 8, 10, but that's okay because it can have more than 8 electrons. So minimizing the formal charge will make it the most correct Lewis structure as D. Okay, so this one over here. Number 8. How many electron pairs are shared between the carbon atoms in C2H4. Now we need to know how to draw the structure for C2H4. So there are two carbons, there are two hydrogens. So if you draw the Lewis structure, it would be something like that. You're going to put the atoms symmetrically and then you draw the skeleton structure. So C2H4, there are two carbons. Carbon is in group 4, 4 times 2, 8, and hydrogens 4. Each hydrogen is 1 electron, 1 valence electron times 4, so 12. So out of the 12, we used up for the skeleton 2, 4, 6, 8, 10. And we are left with 2 electrons. So if you put 1 electron on each carbon, then carbon will have only 7 electrons, 7 shared electrons. But if you erase one of those and then put another one there, I mean, it doesn't look like a, okay, let me erase that, like this. So then this carbon has 8 electrons, but the other one has only 6. So what we're going to do is you're going to put a double bond. You take this lone pair and put a double bond between the carbon. So that will give you this structure. So between how many electron pairs are shared between the carbon atoms in C2H4? There are two pairs of electrons are shared. So the correct answer is going to be 2. Number 9, which one of the following contains a double bond? Again, for this one, you have to draw all the structures. Okay, when you draw all the Lewis structures, you will see that between nitrogen, it's going to be a triple bond if you draw the Lewis structure. So this is the Lewis structure for nitrogen. And iodine, it's going to be a single bond between the two iodine. And then the CH2O, if you draw CH2O, carbon is going to be in the center and there are two hydrogens. The proper Lewis structure will be this. So then between carbon and oxygen, you have a double bond. So this one has a double bond. And C2H2, meaning you have one carbon, another carbon, hydrogen, hydrogen. And between the two carbons, you have a triple bond. And PCl5 is phosphorus in the center. And then you have 5 chlorine bonds. They all are going to be single bonds. So there are no double bonds. So the correct answer is CH2O. Okay. And then the next one. In the nitrate, nitrogen and oxygen are held together by network bonds, dative bonds, covalent bonds, electronegativity, ionic interactions. What do you think is the correct answer? Nitrogen is a nonmetal, oxygen is a nonmetal. So between nonmetals, we have covalent bonds. So the correct answer is covalent bonds. And then for the nitrate molecule, how many resonance structures are possible for nitrate? So first will have to draw the Lewis structure for nitrate. When you draw the Lewis structure, it would be nitrogen in the center and then you have oxygen. Okay. Okay, let's see how to draw the Lewis structure for nitrogen. Nitrogen will be like this. Nitrogen, you have one oxygen, another oxygen, another oxygen, and you will have a double bond between one of the oxygens, and then this is going to be your Lewis structure. So how many resonance structures can you draw for this one? Resonance structures are, you can change the electrons and the pi bonds, but you cannot change the atom placement. So this one is NO3 minus, so this is -1. So that's the Lewis structure for nitrate. Okay, so we can draw another resonance structure where we can put the double bond between nitrogen and a different oxygen. So if you draw that, here's another resonance structure. You can draw like this. So you put the lone pairs on nitrogen. So that's another one. Overall, it has a negative charge. And then you can draw another resonance structure, putting the double bond between nitrogen and the other oxygen. There would be something like this. So there are total 3 resonance structures possible for nitrate ion. So these are the 3 possible resonance structures. Okay. Next one. In which of the following species is the best Lewis structure a resonance structure? Again, oxygen doesn't have any resonance. Ammonia doesn't have any resonance either. Carbon dioxide doesn't have any resonance either. But the carbonate ion does, CO3 minus 2. And SF6, all single bonds, there are no resonance structures. So carbonate, if you draw the carbonate structure, the proper Lewis structure would be something like that. Carbon, oxygen, oxygen. Like this. Okay. So negative 2, this is carbonate ion. So you can draw resonance structures for this one. 2 more resonance structures in fact. So carbonate is a resonance structure. Okay. And then the next one, the best Lewis structure for sulfuric acid has 0 formal charges, sulfur as a central atom and no bonds between sulfur and hydrogen. How many single and double bonds respectively are there in this Lewis structure? Again, you have to draw the sulfuric acid Lewis structure first. So if you draw that, it would be something like this. Sulfur will be in the center. So we are looking at H2SO4. Okay, sulfur in the middle and there are 4 oxygens. Excuse me. There's going to be a double bond between 2 of the oxygen atoms and then hydrogen will be on oxygen. Remember, you had to go by the rules. First you find out the number of valence electrons. For hydrogen, sulfur and oxygen, count them, put the skeleton structure and then you subtract the electrons for the skeleton and then put octet for all the terminal atoms first and then go for the double bonds in the central atom. So if you follow those guidelines how to draw the Lewis structure like we discussed in the lecture, you will come for the sulfuric acid. This is the Lewis structure for the sulfuric acid. Okay. Now for this one, how many single bonds are there? 1, 2, 3, 4 single bonds. How many double bonds? There are 2 double bonds. So 4 single and 2 double bonds are going to be your answer. Number 14. In which of the following does a nitrogen atom have a formal charge of -1? Remember how we calculate the formal charge? Formal charge is calculated by you taking the group number and you subtract number of bonds and number of electrons on that atom in the Lewis structure. Now for the first one, nitrogen, over here, group number for nitrogen is 5 minus the number of bonds and electrons. How many bonds are there? 2 bonds. 1, 2, right? So these 2 are on nitrogen. And then the lone electrons, 2 plus 2, 4. So 5 minus 6, so -1. So the first one, nitrogen, formal charge is -1. What about this one? Let's calculate here also. Group number for nitrogen is 5 minus the number of bonds. number of bonds are going to be 3 bonds plus the number of lone electrons, 2 on the nitrogen, 3 plus 2. So 5 minus 5, 0. And then the next one, nitrogen. A group number for nitrogen is 5 minus the number of bonds 3 plus the electrons 2. So 5 minus 5, 0. And for this one, the group number is 5 minus the number of bonds. There are no bonds in it, but the lone electrons 2, 4, 6, 8. So 5 minus 8 minus 3. It is minus 3. So the formal charge of that is minus 3. So the correct answer for this one is the first one. Nitrogen having formal charge minus 1. And number 15. The formal charges on chlorine and oxygen in the structure shown for ClO minus iron are. Now the Lewis structure is given. We need to find out the formal charge of chlorine. Again, how do you find the formal charge? You take the group number. For chlorine is 7. Group number minus the number of electrons and number of bonds. Number of electrons are 2, 4, 6. Plus number of bonds 7. So 6 plus 1, 7. 7 minus 7, 0. So chlorine is 0. What about oxygen? So for the oxygen, group number is 6 minus the number of bonds 1, number of electrons 6. 6 plus 1, 7. 6 minus 7 minus 1. So chlorine and oxygen 0 and minus 1. Okay, I will stop here and then I'll start the 16 to 13 in another session.